Problem statement from GATE Physics 2021 reads as follows. Two observers O and O prime observe two events P and Q. The observers have a constant relative speed of 0.5 c. In the units where speed of light c is taken as unity, the observer O obtained the following coordinates. For event P, x equal to 5, y equal to 3, z equal to 5 and t equal to 3. While for event Q, x equal to 5, y equal to 1, z equal to 3 and t equal to 5. The length of space-time interval between these two events as measured by O prime is L. The value of modulus of L is, this is a numerical answer type question and we'll have to round off our answer to the integer. Now before we start solving this problem, let's have a look at some relevant concepts. There are some terms which keep coming over and over again in special theory of relativity and it's good to visit them. So first is the inertial frame. So what are inertial frames? These are those frame of references which are either at rest, that means their velocity is 0, or their velocity is constant. This means velocity is not a function of time. So those are the inertial frames. So usually with every inertial frame there is an observer associated. For instance, let's look at this frame. We call it the S frame, or let's call it the rest frame. This means its velocity is 0. It's at rest. So there is an observer in this frame. So this person O sitting at the origin is the observer for this frame. Similarly, let's talk about another frame S prime. This frame S prime is moving at a constant velocity v with respect to the original frame S. So this is also an inertial frame because this velocity is not dependent on time. And here another observer is sitting at O prime. So what do these observers do? These observers will observe some events. So what is an event? An event is denoted, let's say some event P. This may be ball touching the floor, someone clapping their hands. So this event has some space coordinates associated, let's say x1, y1, z1 and one time coordinate, let's call it t1. The same event will be observed, may be observed by this observer O prime and we denote it as P prime. So everything is primed in this frame. So this will be x1 prime, y1 prime, z1 prime and finally t1 prime. Similarly, let's say there is another event Q which is x2, y2, z2 and t2 and similarly it will be denoted as x2 prime, y2 prime, z2 prime and t2 prime. So these are two independent events P and Q which will be seen as P prime and Q prime by this observer O prime. So how are they related? I mean, is there any relation between these two events? Yes, there is. There is an entity called space-time interval which remains invariant across different inertial frames. This means if you calculate this entity delta S for this frame, this will be equal to the entity delta S prime for this frame. So what is this entity? What is this mathematical entity delta S? This can be given by this formula. So this is called space-time interval. We call the first term as time interval. And we call this term as the space interval. Note the space interval is very close to what we are used to seeing as the distance, right? So this is what we call the space interval. Hence the difference of time interval with space interval is the square root of that will be the space-time intervals. Note here the square is here. So that's what space-time interval is. The key thing to note is that the space-time interval remains invariant across different inertial frames. So that is the key thing to note here. Coming back to the problem, before we start solving this type of problems, we do some pre-checks, like whether the first pre-check is whether all the frames mentioned in the problem are inertial or not. So you notice that the question talks about two observers. So let's say this is the observer O sitting in frame S and let's say this is another observer O prime sitting in the frame S prime. And we notice that the question says observers have a constant relative speed of 0.5 c. So let's assume that the first observer is at rest. This means the second observer, this frame, will be moving at a constant speed v of 0.5 c because that's given in the problem. So we notice that the first frame is at rest, so S is inertial. Also, since frame S prime is moving at a constant speed, so S prime is also inertial. So both the frames are inertial. Secondly, we check the speed and direction of the moving frame. So S prime is the moving frame. We notice that the speed is 0.5 c, which is relativistic speed. it's close to C. And we see the direction. The question is silent about direction, so I can simply assume that it's in the positive x direction without any loss of generality. So I can say it's is positive x-axis, and this is the what I'm taking as positive x-axis. This is my y-axis, and this is my z-axis. Thirdly, what are the number of dimensions? So the question clearly talks about 3 dimensions, x, y, and z. So this will be a 3-dimension system using all x, y, and z coordinates, and of course a time coordinate is also there. Now I've just reproduced the problem which was there earlier before. This is the S frame, which we said as the rest frame, and this on your right you have the S prime frame, which is the moving frame, and it's moving at a velocity v, constant velocity v at 0.5 c in positive x direction. You can see the xyz coordinate system, and you can also see both the observers. Now what we are required to do, we are required to find the space-time interval of O prime, so which is delta S prime, also known as delta S prime, and question says that's modulo L. We need to find its value, and these are the P and Q are the 2 events that we know. And now it's very straightforward question. We know the formula of space-time interval we saw is this, delta S prime squared, and this whole formula. The problem here is that we don't know what are the coordinates. Note, we don't know what are x1 prime, y1 prime, z1 prime, and t1 prime. And similarly, we don't know about x2 prime, y2 prime, z2 prime, and t2 prime. So that's a bit of a problem. So we cannot put the values in the formula, and we cannot solve this. But we also know that since both the frames are inertial, S as well as S prime, so whatever the space-time interval squared we obtain for S frame should be equal to the square of space-time interval of S prime square, right? So both the space-time intervals have to be same, and we can say that space-time interval of first frame, the S frame, can be written like this. And we know all the coordinates here. C is taken as unity in this problem. The question says C, you can take C as unity. Delta T we can find T2 minus T1. So let's do that. So T2 minus T1 would be 5 minus 3. 5 minus 3. This would come out to be 2. Delta X would be X2 minus X1. So 5 minus 5. 5 minus 5. This will come out to be 0. Delta Y is Y2 minus Y1. So 1 minus 3. 1 minus 3. This will come out to be minus 2. And finally delta Z is Z2 minus Z1. So 3 minus 5. This will be 3 minus 5. This will again be minus 2. So let's plug all the values here. So this will be 1 times 2 whole square. Note, the value of C we can take as 1. That's given in the problem. Minus delta X squared. This will be 0 square. Minus 2 squared. Minus 2 squared. So if we calculate, this will be 2 squared minus 2 squared and minus 2 squared. So this will coming out to be minus 4. So you can say that delta S is coming out to be minus 4. Delta S squared, sorry. So delta S squared we know. So delta S prime squared will also be equal to minus 4. This implies delta S prime. If you take the square root, it will be 2 iota. Square root of a complex number. Now there are two nomenclatures. We have taken the first, this is called the time interval. We know this is the time interval and this is the space interval. So there are two nomenclatures that are followed. So it's irrespective of that, you will get either plus 4 or minus 4. So but note that we are required to find the modulus of this, right? Delta S prime is the modulus. So we have to take whatever delta S prime is. So we can say L, which is delta S prime modulus. So we can say the modulus of 2 iota will be 2. So value of L, the modulus of L you can say, right, will be 2. So what I can do is that the value of mod L is 2. So we can place this answer here, and it is an integer, so we don't have to round off. So that's our answer. Thank you for listening.